Hello and welcome. Today I wanted to take some time to review solving complex circuits. So here we have this circuit with a 24 volt battery, and we can see there are several series and parallel portions. And I wanted to go over the process of solving for the current and voltage across each resistor individually. So before we do that, there are a couple of things that we need to remember about current and voltage. If we start with current, we want to realize that current comes from the battery, and every time it hits a junction like this, where the wires split, the current splits. So in other words, the current comes from the battery up the wire, but when it gets to this point, part of the current goes up and part of the current goes across. So it literally splits. The same thing will happen right here at this junction. Part of the current will go up, part of the current will go down. And then when it gets back to this junction, the current rejoins back together. And same thing here, our current is going to rejoin and go back to the battery. So current changes every time we cross a junction. Every time the wires split, the current splits as well. As the current moves across individual resistors though, the current does not change. So in this portion of the wire, as the current moves across those resistors, the current is not changed by each individual resistor because the resistors are in series. Current always stays the same in a series portion. So the current through the 7 ohm resistor will equal the current that goes through the 10 ohm resistor. Voltage, on the other hand, is kind of the opposite. Our voltage comes around, and our voltage is not affected by junctions at all. Meaning, as our voltage comes around, 24 volts are going to go that way, 24 volts are going to go that way. And again, at this junction, 24 volts will go across the top branch, and 24 volts will go across the bottom branch. So those junctions don't affect voltage. What does affect voltage is the individual resistors. So as the voltage goes across the 7 ohm resistor, it's going to drop and experience a voltage drop. And then when it moves across the 10 ohm resistor, it'll drop again. And so the important thing to realize with voltage is that in any closed continuous loop around the circuit, our voltage drop has to equal the voltage of the battery. For example, if we start from the battery and we make one loop around the circuit like such, and we take that bottom branch and we go across the 7 ohm resistor and the 10 ohm resistor. Because it's a closed circuit, or closed loop, including the battery, our voltage drop across the two resistors has to equal 24. So the voltage drop of this first resistor plus the voltage drop of the second one has to equal 24. We can also look at another loop. If we look at this loop right here, where we go down across the 4 ohm resistor, and then back around like that. Because this is a closed loop, our total voltage drop has to equal 24 volts. But because we only have the one 4 ohm resistor on the loop, the voltage drop of that resistor has to equal 24 volts. Alright, so with those two things in mind, let's move towards solving our circuit. So the first thing we want to do is find total resistance. And we can find total resistance by first finding resistances of our series portions and then our parallel portions. So we can see in this portion right here, we have these two resistors in series, and then we have these two resistors in series. And so we can combine those two resistors to give us a circuit that's a little bit more manageable. So because these two circuits are in series, the net resistance of those two resistors is going to be 8 ohms. We have our 4 ohms, and then the net resistance of these two resistors is going to be 17 ohms and 24 volts. So now we can see we have all three of our resistors in parallel with each other. So we can use our equation for parallel resistors, which is 1 over RT equals 1 over R1, 1 over R2, 1 over R3. And so when we plug in numbers into that equation, it'll look like this. So when we plug all those values into our calculator, we get 0.4388. But it's very important that we realize that our total resistance is 1 divided by 1 as well. And so when we get this value, we need to remember to take the inverse of that, which will give us a final resistance of 2.3 ohms. So this is our total resistance for the entire circuit. So we can use this total resistance to find our total current of the entire circuit using Ohm's law, which is V equals IR. So using Ohm's law, we can solve for current, which gives us I equals V over R. And since we're looking for the total current, I use a subscript T for total, we need to make sure we use the total voltage and the total resistance. So our total voltage is given by the battery as 24 volts, and our total resistance is what we just solved for, which is 2.3 ohms. So if we punch that into our calculator, we get a total current of 10.41 amps. So this is our total current that comes from the battery. So in other words, it comes out of the battery around here, and then when it hits our first junction, part of it will split to go to the side, and the other part will go up. But this section of the wire right here and this section of the wire right here are the only parts of the circuit that are going to have that total current of 10.41 amps. So now that we have that, we can begin to solve for the current and voltage of each individual resistor. And in order to do that, I'm going to redraw my circuit because these have gotten a little bit messy, and I'm also going to label all of my resistors just so I can keep track of them a little bit easier. Alright, so I've redrawn my circuit. Notice I've drawn it a lot bigger so I can fit all my numbers in. I've labeled the resistance of each individual resistor, and then I've also arbitrarily numbered them as well in green. These numbers are completely arbitrary and chosen at random, and they're there purely to help me keep track of which resistor I'm talking about. So, let's go ahead and start by finding the current of this bottom branch right here. If I'm going to find the current of that bottom branch, I, and then I'm going to use subscript B1 just for branch 1, just so I can be clear in what I'm doing. If I'm going to find the current of branch 1, I need the voltage across branch 1, and I need the resistance across branch 1. So we know since this is a closed loop, across here, the voltage across that branch is going to be equal to the voltage of the battery, which is 24 volts. We also know the total resistance of this branch, since these two resistors are in series, will just equal 10 plus 7, which will be 17 ohms. So if I plug that into my calculator, I get 1.41 amps. So this will be the current that goes across this branch. But remember, current doesn't change because of individual resistors. So because of that, we can also say that this will be the current across resistor number 1, which will also equal the current across resistor number 2. So now that we have the current for each of those two resistors, we can find the voltage drop across each resistor as well. And we can do this again using Ohm's law. So the voltage drop across resistor 1 is going to equal the current in resistor 1 times the resistance of resistor 1. So notice I use the subscript so I know everything lines up and everything correlates with each other. So I plug in values. 1.41 times my resistance of 7 gives me a voltage drop of 9.81 volts. And do the same thing. Our voltage drop across resistor 2 will equal our current of resistor 2 times the resistance of resistor 2. 1.41 times 10 gives me 14.1 volts. So here I can take a second to double check my work. As I just stated, my voltage drop across this closed loop has to equal 24 volts. So if I take these two voltage drops and I add them together, 9.81 plus 14.1 volts, I should get something really, really close to 24 volts. In this case, I don't get exactly 24 volts, which is purely just because of rounding values in my calculator. but it is very, very close, and it's a good way to check your work as you're going. So now that I have the current and voltage for those, let's move to this top section. And this top section is a little bit more difficult, but still not too bad. So I previously calculated that my total current through this branch is 10.41 amps. And then I just calculated that 1.41 amps of it travel across this bottom branch, which means the remainder of that current has to go to the top branch. So I can find my total current going along this top section by taking my total current of 10.41 and subtracting the current across the bottom branch, 1.41. And so when I subtract these, I get a current of 9 amps. And so I know 9 amps are going up this top section. But right here, that current splits again. Part of the current is going to go down, part of the current is going to go up. But the other thing that I know, because of what we discussed with voltage, is that in one continuous loop, our voltage drop has to equal the total voltage of our battery. So if I start here and I move around and I go through this bottom branch right here, that voltage drop has to equal 24 volts, which means this bottom resistor, the 4 ohm resistor, has to have a voltage drop of 4 amps. 24 volts, sorry. So I can use this to solve for the current through resistor 3. So the current in resistor 3 will equal the voltage drop of resistor 3 divided by the resistance of resistor 3. So my voltage drop is 24 volts and the resistance is 4, giving me a total current of 6 amps through that resistor. So now that I know that 6 amps go down this way, that means the remainder of my 9 amps have to go through the top branch. So 3 amps have to go through the top. And again, since these two resistors are in series with each other, that means that the currents are equal through them. So in other words, my current through resistor 4 will equal my current through resistor 5, which is going to equal 3 amps, because 6 goes down and 3 goes up. So now all I have to do is find voltages. So voltage drop of resistor 3 is going to equal the current of resistor 3 times the resistor of resistor 3, which we can do pretty simply, is 6 times 4, which equals 24 volts, which we should have already known. But it's nice to double check to make sure that we're doing things correctly. We can do the same thing with 4 and 5. So the voltage across 4 will equal I4 times R4, which will be 3 times 5, which will give us 15 volts. And then V5 is just going to be I5 times R5, which will give us 3 times 3, which is 9 volts. And so again, we can double check ourselves by adding these two together, and we should get 24 volts because that is a closed loop around the circuit. So that's a quick summary of how to solve for complex circuits, solving for both current and voltage through the entire circuit. You can do the same thing with much more complicated circuits. Same process, is just much more time consuming. Anyway, I hope this has been helpful.